Hi guys, my name is Ernest and this is Ernest's Sciences and Mathematics TV channel. In my channel I deal with the different aspects of mathematics and sciences. You can find us on YouTube by searching Ernest's Sciences and Mathematics TV channel. Subscribe and share with your friends and also engage us on the comment section so that we can be having a discussion concerning these specific topics. So for today we're going to look at the concept of integration of a trigonometric function. And this is going to complement on various topics, especially that we have done on trigonometry and the concept of integration. And this, of course, is going to also add up on some of the areas that we have looked into, especially on the concept of integral of ordinary functions, the integration of exponential functions, and also the integration of logarithmic functions that we had mentioned. So this is going to add up on these specific areas whereby we're going to see how we can be able to treat trigonometric functions insofar as the concept of integration is concerned. Now we're going to achieve this by using a few examples, and at the end of the discussion we're going to of course see how we can be able to tackle various problems which fall under this category of trigonometric functions insofar as the concept of integration is concerned. Now in this specific discussion I'm just going to have a recall of a few concepts that we have especially learned, and perhaps give a few of which you need to learn in order to understand this specific topic. So from trigonometric ratios, we have said that we can be able to have what we call identity, and we are given an acronym for us identifying various trigonometric ratios that we are given for sine, cosine, and the tan of theta. And there are other various derivatives that we have talked about concerning the concept of cosec, sec, and the cot of these various basic trigonometric functions, as we said. So therefore, in this case, we have talked about the concept of identity functions. And one of the examples that we are given is, let's use the letter x to represent this variable for the sine, cosine, and perhaps tan of theta. I'm going to use x. So if we have the square of the sine of x and the square of the cosine of x, these are going to give us unit. So therefore, this is what we call an identity function, and therefore we're going to apply it in some of the aspects that we're going to discuss today. So from this we have different, or rather some of the derivatives of this specific identity function, and we're going to see it later being applied. But of essence for us is to try and, of course, elaborate on some of the laws that are going to be applicable in our discussion today for integration of our trigonometric functions. Now we had said in our discussion on derivatives that the d or dx of the sine of x is equivalent to the cosine of x given. So from this one it implies then therefore that the integral of the cosine of x dx is going to be what we refer to as the sine of x plus c. So, and again we have said that for us to obtain the integral of the sine function, we're going to have it given as d over dx of the cosine of x is equivalent to what we refer to as negative the sine of x. So implying that the integral of this specific concept of the cosine of x, the sine of x, is going to be, so this is the integral of the sine of x dx is going to be negative cos x plus c. So this comes from this specific derivative whereby we're going to have this specific cosine d over dx, the cosine of x given as this negative the sine of x. Therefore we're going to have this one given as the negative cosine of x plus c, and this is the sine of x plus c, which are going to be given as such. So the combination of identity plus these two specific basic trigonometric functions are going to assist us in trying to evaluate one of the examples that I'm going to give on the board. And as we go by and discuss, we are going to see various variant ways in which we can be able to describe the odd powers of the sine and cosine function, and even the even powers, which are going to be treated using some specific procedure in that specific respect. So therefore, in some areas as well, we're going to use some of the specific laws that we have discussed, especially on the single power rule of integrals and the exponential rule and other areas where we're going to find it applicable. So I'm going to use this specific example on the board, whereby I'm going to evaluate the concept, rather the cosine of x, the x given as such. So this is going to fall under the category of what we refer to as the odd powers of the sine and the cosine of x, whereby in this specific case for 3 it's the odd power. So therefore I'm going to use some specific. So in any case I'm going to do some expansion or rather some elaboration on various steps that we're going to do in order to obtain the answer for our specific calculation. So therefore, given this specific integral and requested to solve, we're going to write another question for this, whereby we're going to have it as an integral of the cosine, the square of the cosine of x dx, which of course is this is a multiple of this cosine, the cosine to power 3 of x given as such. So therefore, we have said that from the identity that I've given, the cosine of x, the square of the cosine of x and the square of the sine of x are going to give us an identity, so we a unit which is 1. Therefore, we can be able to express the cosine of x, the square of the cosine of x in terms of the sine of x and this unit. So therefore, the cosine of the square of the cosine of x is equivalent to 1 minus the square of the sine of x are given as such. So doing a substitution in this specific integral, then therefore it's going to imply the integral of 1 minus the sine of the square of the sine of x, and then we are going to have this one cosine of x dx given as such. So in this particular case, we can be able to open these brackets. So therefore, we're going to have the integral of the cosine of x minus the cosine of x sine the square of the sine of x dx given as such. So I've just opened those specific brackets. So from this one, we can be able to use the rules of addition and subtraction in order to find the integrals of those two specific functions. So therefore, it's going to be distributive in a way that we can be able to write it as the integral of the cosine of x minus the integral of the cosine of x sine the square of the sine of x dx. So this one is going to be the integral of the cosine of x dx given as such. From the two illustrations that are given for the specific laws of integral of the function of the cosine, we had said that this is going to be given as the negative, not really the negative, the sign from a derivative that are given for the integral of the sine, the d, we are going to have here to recall that d over dx, the sine of x is given as the cosine of x, implying that the integral of the cosine of x dx is equivalent to the sine of x plus c. So therefore, the integral of the cosine of x is going to be the sine of x plus c as we had written. So therefore, we're going to proceed from this one and have this one as the sine of x for the first one minus. So for the second case, we're going to have a representation whereby we're going to let the sine of x be represented by a specific letter, whereby we can be able to choose a letter whereby we are going to have it given as, so this is going to be the integral of the sine of x, the square of the sine of x dx, and we say let u represent the sine of x, so therefore the derivative du over dx is equivalent to we have done the derivative of the sine of x, which was given us the cosine of x. So du over dx is going to be the cosine of x, implying that dx can be represented as du the cosine of x. Therefore, doing a rearrangement of a specific function from this specific point, then therefore we're going to have this one given as the sine of x, which is going to be represented by u, minus the integral, or rather we can just use this one to solve, okay, minus the cosine of x, and then the square of u dx is the same as, of course, the du over the cosine of x. So if you try to look at this, we can have this specific part and this one cancel out. So the last bit of it is going to give us, can just which part, can just push this one over here, so that we do not lose our integral. So I'm going to have it as the integral of the cosine x dx given as such. So I'm going to use this space in order to evaluate that. So from here, then therefore we're going to have it as u minus the integral over the square of u du. Now the second part of it is going to give us u minus u to power 3 over 3 plus c. So in this case, we can be able to do a substitution from our specific representation for u and try to put in what we had substituted it for the sine of x, whereby we're going to have this as the sine of x minus the sine cube x over 3 plus c given as such. So for us to find the integral of this, as we're going to see, we're going to give it through various steps that I've given, whereby we are going to have it as the cosine of x. We're going to have to rewrite this one in form of the cosine of x, square of x plus the cosine square of x and the cos x dx, whereby we're going to use the second one as an identity and then try to do a substitution in our integral. And then therefore, in opening these brackets, we're going to obtain this specific function. And of course, we are going to find this one from the identity or the specific derivative rule that had given, which was giving us an integral of the cosine of x, which is the sine of x. Now for the second part, we're going to do a substitution for the sine of x, and therefore this is going to give us an overall equation for substitution for u for sine of x, the cosine of x, whereby the value for dx in this specific case is going to be du for dx from this specific derivative. So therefore, doing a cancellation for this is going to give us this, and from there, then therefore we can be able to achieve this and do a substitution to find the final product of our integral as the sine of x minus sine cube x over 3 plus c. So this is one of the ways in which we can be able to obtain the integration of our trigonometric functions. Now in our other cases, we're going to look for ways in which we can be able to solve the even cosine and the sine functions, which are going to be done in our next video. So that is it for today, guys. Catch us in our next video. Bye. God bless.